To the new lesson. Today we are going to study 3. 3 is also a data structure which is widely used to represent hierarchical structures. Like in this diagram you see, one node is used as a root node, and then this root node has children. And to the extent of this lesson, we study only those three structures that has the maximum of 2 children. But in future lessons, we may cover more lessons that has more than 2 children as well. But within the context of this lesson, you see that every node can have maximum 2 children, or one children or no children. For example, this node, which is the root node, it has 2 children, this one and this one, and this node has also 2 children, this one and this one, but this node does not have any children. However, you should know that in this lesson the tree that we discuss has maximum of 2 children. Okay, and let's represent this tree in programming. When it comes to programming, we need to have two classes. One class to create the node, and the other class that represent the tree itself. And tree is actually a pointer to the root node. For example, in these nodes, in these codes, let me write a separate example in order to make it more clear. 3.js. So we need two classes. One class to represent the node, so I name it tree node. So as you see the tree here, within the extent of this lesson, every node has three properties. One property can be the data value, this dot value or data, and we have to pass this value when we are creating its object. So this value, this dot value equals value, and two more properties. One property or two pointers. One of them points to the right child, and the other one points to the left child. So you can say you can give it any name, but if you give like right and left, that is more meaningful. So in this lesson also I give right and left names. So this dot right equals null at the beginning, also this dot left null at the beginning. So it is the node class, and also we need one more class, which is the tree itself. Class tree. This class has only one property, which is the root property that points to the first node in the root. So constructor this dot root equals null for at the beginning. So now let's consider this tree. If we want to represent this tree in programming, so I have two classes. I have created the classes, and now for every node we need to create an instance or an object of this tree node. So I'm saying that let I give the name as they have a label right now. So I'm saying let a equals new tree node. I create an instance of that node, and it has one value. the value is given directly through its constructor, and let's give directly the label that they have. For example, I pass the character A, and then let B equals new 3 node. I pass B, and let C equals new 3 node C, and let me take a copy of them, so we don't need to write like all of them. So C, D, E, and F. So it is D, it is E, and it is F. So now we created the nodes, the instance or object of this node class. However, still it is not a tree. We say that tree is a data structure that has a root node, and that root node has children. So now let's create an object of this tree class. Let I name it tree equals new tree. So this tree class has one property, which is the root, and this root points to the first node in the tree. That means the root has to point to A. So I'm saying that 3.root equals A. So now A has two children, B and C. So A dot left has to point to B. Like we said, every node has three properties. One of them is the value, that the value is A, value the past, and it has two more properties. One is the right, one is the left. This two pointer points to the children. So I'm saying that A dot left equals B. Here we can see A, its left child is B, and A dot right equals C. Also, C has only one child, and it is its right child. So I'm saying that C dot right equals F. And also we can see B has two children, right and left. B dot left equals D, and B dot right equals E. So now it is our tree. First we created two classes, and then we created their objects. So we defined that every node in the tree has three properties: the value, pointer to the right node, and pointer to the left node. And we set all the pointers here. Now we can say that we have a tree here. Okay. There are some specific operations with the tree that we study them in the next lessons, which are inserting an element, removing an element, searching for an element, deleting for an element, traversing an element. For example, right now that we created this tree, you want to add a new child for node C, or you want to add a new child for node F, or you want to remove a child. So we will cover all those operations in next lessons. Until then, have a nice time, everyone.